Hey guys, and welcome back to another one of these A-Level live streams. So today we're actually starting the statistics. So I know a few of you have been asking for the statistics and mechanics, so we're going to start with the statistics and move on to the mechanics a bit later. But we're going to do it in like really small chunks, okay? This is just so you're able to kind of pick exactly what you want to know or what you want to go over. So this is, at the moment, it's just going to be the histograms part of AS statistics. So we'll go through these questions, and these are all the questions from the exam papers and everything. And then we'll move on to the next ones in the following lessons. So the partially completed histogram and the partially completed table shows the times taken to the nearest second for a group of people to complete a puzzle. So the key thing to remember about histograms is, so a few things. So first of all is that the frequency density, which I'm just going to abbreviate to frec dense, is just the frequency over something called the class width. And the class width is just the upper and lower boundaries of the class subtracted from each other. So one thing that you should definitely know though is that if you look at these boundaries, they're not actually correct, right? So if you look here, this is actually at 4.5 and 8.5, not at 5 and 8. And this is because there should be no gaps between classes when you're talking about histograms. So, if we get started, we need to basically fill in the rest of this. So the first thing I'm actually going to do is write down all of the actual class widths. Okay? So what we're going to do is make sure that there's always overlap in the classes themselves, which will help. So yeah. And now if you look, there are no gaps between the classes as intended, and again you can actually read these from the graph. So, if we look here, the first thing you need to do in any histogram is you're going to work out the frequency density, and again that's just going to be the frequency divided by the class width. So if I get the calculator up, in this case it's going to be, so for the first kind of row, it's going to be 2 over 4.5 minus 0.5, okay? Which is just a half. So we're going to write it in terms of decimals though, because fractions don't particularly help us. And we're going to keep going and keep doing it. The next one is going to be 12 divided by, that's going to be 3, right? Which is 4. Then it'd be 8 divided by 2, which is also 4. This one we don't know, we're going to have to read it from the graph. And the last one is 3 divided by 5, which is 0.6. Okay? So, what we will need to work out is we need to work out the frequency density of this middle class here, which is the one that represents 10.5 to 15.5. So if we think about how we can do that, well, we need to know what this graph goes up in. So if we look at this bar here, that's 4.5 to 8.5, that's this one. So this frequency density up here is 4. Okay? So now what we're going to do is we're just going to count the number of squares, and we're going to divide 4 by the number of squares in order to get how much is in each. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what we do is we take 4 and divide it by 15. It should also be noted that generally speaking in exams they will put like bigger squares, so they'll kind of group the squares together, but in this question they haven't. So that is 4 over 15. Good. Oh, hang on one second. I made a mistake here. That should be 3. So it's actually going to be 3 divided by 15, which is 1/5. So each box goes up in 0.2s. So we can put 0.24681, 24682, and then 24683. 2, 4, 6, 8, and then 4. So that gives us the actual indentations there, the kind of increments that we have. Perfect. So now we can actually read off what the frequency density is for 10.5 to 15.5. It's 2. So the frequency density is 2, and we want to work out the frequency. So if we rearrange this, frequency is just equal to the frequency density multiplied by the class width. So we're going to take 2 and multiply it by 5. So the frequency there is indeed 10. Perfect. Okay, now we need to actually draw the rest of the bars. So I want to ask for your consideration here. I suck at drawing at the best of times, and normally speaking, there isn't going to be any gaps between any of the bars. But in this one, since we start at 0.5, there will be a slight gap because we're going to be starting here. But that's okay for this one. Frequency density is 0.5, so that'd be 2, 4, and then midway up here. So it'd be something like this, and go all the way, touching the graph. Again, you should probably use a ruler for this, but let's just move swiftly on. The next bar is 4.5 to 8.5, we've already given that. 8.5 to 10.5, which is middle bit here, should go up to 4. So let's go all the way up. Oh. It's that one there, and the last one's 15.5 to 20.5. So that would be all the way up to the end here, and that should be 0.6. So 2, 4, 6. Like that. And that is how you complete the histogram for that one. So hopefully that's not too bad. Hopefully that kind of makes a fair bit of sense. Again, histograms we have done in GCSE, so I'm hoping it's not too tricky. And again, that's for part A, completing the table, part B, completing the histogram. Lastly, part C, it says one of the participants is selected at random. Estimate the probability that this participant completed the puzzle in under 10 seconds. So 10 seconds is all of this stuff here. I'm going to draw a dotted line, and it's all of this stuff here, all of these probabilities. So we can work this out. We already know what the frequency of this first bar is. It's 2. Frequency of the second bar, we know that is 12. Now we don't actually know what the frequency of the third bar is, because keep in mind it's not the whole bar, right? It's up to this dotted line. Okay, and if you look at it, how much of the bar do we have? Well, if we have a look, it should be from 8.5 to 10.5, but we're only going up to 10, right? Which means we're leaving out 1/4 of the value. So as an estimate, and this is where the word estimate comes in, we're going to take 3/4 of 8, because we're only using 3/4 of the bar. Now this is an estimate because in this grouped data, we don't actually know how it's distributed. The assumption here is that it's uniformly distributed. So there's an even number of 9s and 10s, right? So maybe 4 9s and 4 10s. That's what we're assuming, okay? Or in this case, it would be actually, what would it be? 2 8.5s, 2 9s, 2 9.5s, 2 10s, and 2 10.5s. You know, it'd be an even distribution like that. So we have to take 3/4 of it. But again, this is where the estimate actually comes in. Now if we equate this, we get 2 plus 12 is 14. 3/4 of 8 would be 6. So in total we have 20. So the probability, and again this is for part C, is going to be 20, the number we have, over the total. And if we have a look at the total, it doesn't actually tell us. So 2 plus 12 is 14, 22, 32, 35. Which again would just be 4/7. And that's it. So again, remember when you're estimating probability, you're looking for the number that you want over the total. And again, but in this case, the number that we want is actually part way through the bar. So we have to take that into consideration. Question 2 is another kind of common type of question that they like to give you. So they're giving you a variable x, doesn't matter what it is, measured to the nearest whole number. 50 observations are given in the table below. Once again, if you look, the class widths are actually incorrect. So again, a lot of the time they actually give you correct class widths, but again there are some of you out there that are going to come across questions where they don't give you the correct class width, so all you need to do is correct them by yourself. Okay, something like that. Histogram was drawn and the bar representing the 9 to 13 class had a width of 2 centimeters and a height of 2.7. Find the width and height of the bar representing 14 to 20. Okay, cool. So we have this bar, right? And it's going to have a width of 2 centimeters and a height of 2.7. Now, what we can think about is if we had a 1-to-1 scale, right, where one frequency density was 1 centimeter, what would the bar look like? So we're going to have this bar over here. Now the first thing we can do is actually work out the class width. This is the 9 to 13 class over here. So 13.5 minus 8.5 gives us 5. So it's 5 units. Okay, and the height, well, that's going to be a frequency density thing, right? So if you want, we can work out the frequency density down here. 9 divided by 5 is 1.8. Like that. So what we can do is we can have a look at what the scale is along the x-axis and along the y-axis. So to go from 5 to 2, all we do is we take 2/5, which is 0.4. To go from 1.8 to 2.7, all we do is times by 1.5. And again, the best way to work this out, by the way, just in case you're wondering, is this 1.5 comes from, all you do is you take the value on the right, divide it by the value on the left. They're common by 0.9. If I divide both by 0.9, I get 3 over 2, which is indeed 1.5. Same thing here, right? I take 2 divided by 5. 1/5 is 0.2, so 2/5 must be 0.4. Okay? So now I know this, I can now do the exact same thing for the 14 to 20 class. So we're going to say this is 9 to 13. Then for 4 to 20, right, put a little line underneath. What the height and width should be, well, the width is, if we're going from 14 to 20, which is this one here, it's going to be 7, right? What would the height be? So we have 14 divided by 7, that'd be 2. Then all we're going to do is times by the exact same scale factors in order to work out what the height and width would be here. So we're going to times that by 1.5, which gives me 3 centimeters. We're going to times this one by 0.4. It's a bit harder to do, so let's do 7 times 0.4 on a calculator. 2.8. Actually, that wasn't too difficult, was it? So the height would be 3 centimeters and the width would be 2.8 centimeters. Okay? So again, it's a question that they like to ask you quite a bit, and we're going to do another example question on that right now. So again, we have a variable y that measures the nearest whole number. So again, what we need to do is go through and add the correct class widths, or the boundaries. There we go, okay. And once again we have a very similar thing. So the 10 to 19 class, let's just do this. And this question gives us a little bit more practice on doing this. So what it should be, and then what it is, has a width of 2.5. And has a height of 2.6. So the width of the 10 to 19 class should be 10. And 13 divided by 10 is 1.3. So to go from here to here, 2.6 divided by 1.3, well, I happen to know that that would just be 2. And here that's just going to be a quarter, so times by 0.25. Okay. So keep going. So part A, we're going to do the exact same thing, the 20 to 24 class. So if you notice, by the way, is that if you took the class width of just this 19 to 10, it would just give you 9, whereas the actual class width is 10. Because again, keep in mind you have to do the kind of filling in. So you will get the answer completely wrong if you don't do that. So be 100% careful of that. So 24.5 minus 19.5 will give you 5. And cool. So 7 over 5, which is 1.4. And then again, the real width and height. So that would be 5 over 4, which is 1.25 centimeters. Which again makes sense, by the way, because 10, 5, so it should be half as wide. Probably didn't have to do all that, but that's fair enough. And that should be times by 2 if I remember correctly, which could be 2.8 centimeters. Yeah, times by 2, perfect. And then for part B, you're doing exactly the same, but for the 25 to 28 class. So again, class width is 28.5 minus 24.5, which is 4. and the height is going to be 5/4. No, sorry, 15/4, which would be half it, 3.5. Okay, and then once again, do the exact same thing to work it out. Excuse me. 1. I know stats is a bit of a pain. I do agree with that. But it is kind of necessary. It gives you 1/6 of your overall grade comes from this, so we just got to do it. And yeah, so this is kind of just based on histograms, and it is just the same thing over and over again in terms of this. There's not too much going with this, but again, this is just one part of AS stats, so I really want to take this nice and slow, just to make sure that you're okay, because again, as someone just said, I hate stats so much. Stats is very, very difficult, it's very annoying, there's lots of little tiny details and little tiny things, so I think it makes sense for us to go through it slowly rather than just me slamming 5 topics together and trying to get through it. So this lesson will definitely be less than an hour. In fact, we only have one more question, so it'll be about 20 to 30 minutes. But at least this way, we'll get through things carefully and be 100%. And yeah. So again, last type, again, finding the height and width of these classes, okay? But this is pretty much all they can ask you. They can ask you to find heights and widths of classes based on information they give you before. Hardest stats would probably be, in my opinion, hypothesis testing. So using the binomial or normal distribution for doing that. But hypothesis testing is considered the hardest one, at least in all the students I've taught. So one thing to note is that with your kind of stats exam, you tend to have 5 questions, okay? One question is always hypothesis testing. One question is always on box plots. One question is always on AS or A-level. I think overall, really. Actually, AS stats is the hardest is hypothesis testing. A2, there's hypothesis testing but for different distributions. So it's slightly different. It's a bit closer. But for AS, definitely hypothesis testing binomial distribution. 100%. But if you're talking about, as in what I'm talking about right now, overall, your actual stats and mechanics exam, there's 5 questions. One of them is it's 100% for your actual final A level. One is always hypothesis testing. Okay, one is always box plots, etc. The 5th question is a bit of a oddball. They could put histograms and they could put a few other things in there as well. It could be another hypothesis testing. So just keep that in mind. Yeah, I think we've started off with a fairly easy kind of stats, and we're going to go through a few more bits later. Regression can be kind of seen as somewhat difficult. Interpolation and standard deviation is pretty tricky in some cases. Other than that, I don't think it's too bad. Probability, I think, gets a bit easier, because obviously you have the binomial distribution, which you can just use on your calculator. Yes. It's 4 or 5, I can't remember, but they both have the same amount. So that's why I said 1/6 of your paper is stats, 1/6 of your grade is stats, 1/6 is mechanics, and then you have basically a third for, well, sorry, half for, well, a third for pure 1, a third for pure 2. So, and this literally is paper 1 and paper 2. It's a third, and then you have your paper 3, which is applied, right? And you have stats and mechanics, which are a 1/6 each, which adds up to a third, right, overall. Actually, you know what, I can quickly double check what I just said. So what I'm saying is correct, it's just I can't remember how many questions it was off the top of my head. I believe... yeah, it's 5. It's 5. And that's always the same. And to be honest, if you even look at these applied papers, it's always the same type of question, right? Like 100% you'll get hypothesis testing, right? So if you wanted me to predict it, one, you have hypothesis testing. Next, you're going to be using binomial or normal distribution to work out